Okay, so in this question, you're looking at drawing a dot cross diagram for an ionic compound. So, a couple of things you have to remember here. First thing you have to remember is that negative ions can't be next to each other because they will repel. So they have to be separated. The other thing to say is that a positive ion can possibly be drawn in two ways. First way is to draw it with 0 electrons in the outer shell. The second way is to show it as if you've completely lost the outer shell and therefore you've gone to your inner shell and you're drawing your completed inner shell. So the only two possibilities for magnesium are with no electrons in the outer shell, as shown here, or with a complete electron shell. The final thing you have to recognise is that the hydroxide ion, even though it is ionic, the bond between the oxygen and the hydrogen is a bond between two nonmetals and is therefore a covalent bond. So you have to show an overlap between the oxygen and the hydrogen, where the oxygen and the hydrogen share a pair of electrons, making that covalent bond. And obviously you've got exactly the same thing for the other oxygen-hydrogen. Okay? So you get 1 mark for the magnesium being correct, and 1 mark for the hydroxides being completely correct. To get the second mark, if you draw both of the hydroxide ions in, they have to be either side of the magnesium so they don't repel. They also have to show the covalent bond between the oxygen and the hydrogen. In the next question, you're asked to work out an equilibrium constant. You know that because I've got Kc, the only factors I can include are where I have a concentration. By definition, species that are solids at room temperature and pressure do not have a concentration and therefore do not show up in your Kc expression. Equally, I can work out the value power to which my concentration are raised by looking at the stoichiometric number in my equation. So number 2, therefore I raise it to the power 2. Same with the sodium hydroxide. So the first thing I need to do after I've worked that out is to look at how I calculate the number of moles of sodium hydroxide. Okay, so it tells me in the question that I have 100 centimeters cubed of sodium fluoride solution of a concentration 0.25 molar. It also tells me that the mixture is filtered and 25 centimeters of the cubed solution is removed and titrated with hydrochloric acid. And it also tells me that 0.1 moles of hydrochloric acid of concentration of volume 11.7 centimeters cubed is required to neutralize the sodium hydroxide. So I know my ratio between hydrochloric acid and sodium hydroxide is 1:1. So I know I can use those values to work out what my number of moles of HCl is, and therefore, because I've got a 1:1 ratio, what my number of moles of sodium hydroxide is. So that's your first mark. Once I've worked out what the number of moles of sodium hydroxide is, I know that my volume is 25. It tells me that in the question. I have to convert that into decimeters cubed by dividing by 1,000. So I know my concentration is 0.0468 moles per decimeter cubed. So that's your second mark. Your third mark is for your correct Kc expression. Your fourth mark is for working out the equilibrium concentration of the sodium fluoride. Now, it tells you in the question that you start off with 0.25 moles of sodium fluoride. But remember, the sodium fluoride is reacting to make sodium hydroxide. So if I've ended up with 0.017 moles of sodium hydroxide, I've therefore used up some of my sodium fluoride. So I have a new concentration of my sodium fluoride. The concentration that I started off with minus the concentration of my sodium hydroxide. So therefore my equilibrium concentration is 0.2032. So my calculation is 0.0468 squared divided by 0.2032 squared. And that gives me an answer of 0.053. That is my fourth mark. My fifth and final mark is for working out what the units are. Right, so I know that I've got moles per decimeter cubed times moles per decimeter cubed, which is moles to the 2 dm to the minus 6, and that's divided by moles per decimeter cubed times moles per decimeter cubed, which is again moles to the 2 decimeters to the minus 6. Therefore, there are no units. And that's your fifth and final mark. The next question is looking at would the experiment be improved by repeating it on different days? Now the answer to that question primarily is no, because on different days you're going to have a different temperature and different pressure. But if you can ensure the temperature and pressure is exactly the same, because you're in a temperature controlled room with a thermostat, and the thermostat can also control the pressure, then the answer would be yes. Obviously, repeating the results makes a better mean. Okay? So the answer is it depends if you can control the temperature and the pressure or not.